Hey there and welcome. Today we are talking about Django database functions. Django comes packed with a rich set of database functions, but which ones are actually useful in real projects? In this video we'll cut through the noise and focus on the most practical ones, while also covering a few edge cases. We'll touch on performance tips and even pick a true sequel for those unavoidable situations. Let's get started and level up your Django queries. Let's start with comparison and conversion functions. In this section we will cover 5 key functions, such as cast to convert data types directly in your queries, Coalesce to handle null values by providing fallback options, Collate to specify sorting or comparison rules for textual data, greatest and least to retrieve the largest or smallest value from a set of fields or expressions, and JSONObject to construct JSONObject directly from the query result. These functions are game changers when you need dynamic adaptable queries. Now let's see how they work in action with some practical examples using our familiar models. Starting with cast, we can use it to convert the type of a field. For instance, if we want to set the discount price as the integer part of the original price minus 10, we can use cast to achieve this. Let's run it and see the result. As we can see here, discounted price is correct. Most likely you'll use it to handle errors related to incompatible data types. If you encounter such an issue, you can always use cast to ensure you are working with the same data types. Next, let's tackle missing values using Coalesce. Suppose we want to apply a custom discount rule to our books based on the discount field. In this example, the discount field is set to 50% when the book's price exceeds 20, otherwise it's set to none, simulating the real database scenario where the discount is previously determined. Let's run it and see that it was actually applied. What we aim to do here is annotate the final price based on the discount, which we already got. To calculate the final price, we'll apply this rule. If no discount is present, we apply a 10% discount, otherwise existing discount will be used. And after running this, we'll see that books priced below 20 get 10% discount, and books priced above this received 50% discount from previous example. Coalesce is highly versatile. It can be used not only with numeric fields, but also with strings or other type of fields. Here is an example how it's used with char field to display non-values if discount is missing as not included. Now, let's use Collate to specify custom filtering rules, especially when dealing with case-sensitive data. For instance, if we want to filter books by their title in a case-insensitive manner, we can achieve this by annotating a new case-insensitive field. When we compare the results after running these two queries, we can see that it actually gives us the correct result. The first query did not find any books that match the specified string, but when we did it in a case-insensitive manner, we actually got the result back. To retrieve the largest or smallest value among multiple fields, we can use greatest or least. For example, if we want to get the highest value between price and discount, we can construct code like this. But for better feasibility, let's say if we don't have a discount set, we will use 100 as a value, and then see the result using greatest, which are correctly applied here. And list, after changing the function name in query set. It can also be used with date, datetime field, char field, and any other numeric field. Finally, JSONObject. lets you construct JSON object from query result. This is especially useful for exporting structured data. Here's how you could create a JSON object with a book title and price, and that's an output of it. Next topic here is time-based queries. Handling date and time in database can get tricky, but Django ORM offers some excellent tools to simplify this. In this section, we'll cover a few key functions to manipulate and query time-related data effectively. Here's what we'll be exploring. Extract, to pull specific components like a year or months from date fields. Trunc, to truncate datetime fields to a specific level, like day or hour. Now, to get current date or time for dynamic filtering. First, let's take a look how to extract parts of a date or time. Say we want to know which books were published in a specific year, like 2014. Here we are annotating a new field using extract year, which will be equal to the extracted year from each object published date value, and then we can filter by this field. After running this, we can see that only books from 2014 returned. Following this pattern, we can construct more queries using extract functions like day, hour, minute, second, months, quarter, week, weekday, ISO year, and regular year. Some of them can be replaced by using this kind of a lookup during filtering, but not all of them. Previous example can be done this way, as Django ORM supports direct lookups for year, day, week, weekday, etc. Next, truncation comes in handy when you want to group data by a specific interval, such as day or months. It's extremely useful during some search filtration in web applications. Suppose we want to group books by the months they were published. Here's how we can do this using trunc, and then we can do any operations with each group, like count in here, and see how many books were created for each month. Or sum to get the total price of all books for each trunc period, etc. This construction is very powerful and can be used with many truncation types like year, months, week, quarter, date, time, day, hour, minute, and second. Also, what we just explored here is a group by technique with Django ORM. We will dive deeper into it in future episodes. Next bit in this section is Django's null function. It's great for dynamic time comparison, returns the database server current date and time when the query is executed. For example, suppose we want to find all books published in the last number of days. That's how we can do it. But it can also be replaced with regular Python datetime operation in most cases, like this one, where you're just using regular time zone now from Django utils, and see that the same result is returned. Now, let's talk about string functions within DB and Django ORM. Django ORM comes with a robust set of tools for manipulating strings right in your queries. This includes basic transformation like upper and lower to change text case, and more advanced functions like concat for combining fields, length to measure the text length, and replace for substitutions. For example, here we are using concat to combine two upper strings of a book title and some upper text. While Python can also handle strings effectively, leveraging ORM string functions directly in queries reduces database to Python overhead and ensures optimal performance for large datasets. Check out Django's documentation for the full list of text functions. The ORM also provides built-in support for mathematical operations that help you handle numeric fields without additional processing in Python. Here we are taking a total count of books with rounded average price on them. And also here we are finding the total price of all books. Let's run it and see how it looks. Math functions are not just limited to basic functions like sum, count, round, average. Even trigonometric operations like cos and sin are also available. While not all may be commonly used in everyday applications, they can come in handy for specialized use cases like scientific or financial computations. Sometimes Django's built-in database functions don't cover everything you need. With Func, you can create your own functions for special scenarios. Let's look at an example where we calculate double the length of a book title. It can be used really widely, depending on your SQL experience. Here, we define a custom SQL function, double title length, to calculate the doublet length of a book title. This allows you to keep complex SQL logic within Django ORM. Any built-in SQL function can be used here. Let's run it and see how this function works. And the length of title is doubled. Sometimes you can face a case where you need to construct some complex DB query, and when you need this flexibility, the row method lets you write custom SQL while still mapping results to model instances. Let's say we want to select all books with a price greater than 20. After running this, the result is mapped to a Django regular query set. This is perfect for receiving data with complex queries that ORM doesn't support out of the box. However, keep in mind that row doesn't give you the same safety checks as ORM queries. That's it for today's video. Thank you for being here. Everything you've learned today not only can, but should be combined with the knowledge you've gained from previous videos. Stay tuned and I'll see you in the next one.